Hello, today we're going to go over all of these different parts of an exponential graph. We want to know what A, B, H, and K do to the graph. So I'm actually going to go ahead and show on half of my screen this graph to the right. And what we can do is we can start moving around the A values, and this is what you were supposed to do with your sum or with your exploration up above. So if you move A, notice how it stretches the graph vertically, but then if A is negative, it also reflects it over the x-axis. So A is going to do two things. It stretches the graph vertically, and that's if A is greater than 1. If A is a fraction, it's actually going to compress vertically. And so if A is in between 0 and 1, or normally a fraction, that's going to compress your graph. And so that's the first thing. It stretches or compresses. But the other thing it does is it reflects over the x-axis. And so that's if A is negative. Okay, so through our exploration, that's what A did to your graph. So I'm going to kind of reset it kind of close to 1 here. And now we're going to look at B. So B is your base. This is a good one to identify. We've been talking a little bit about your bases before, but here it is again. So B is your base. Depending on your base, your graph is either going to be growth or decay. And so your graph kind of looks different based off of those. So it's going to be growth if your base is greater than 1. So it can be like even 1.1 and it would still be growth. Or it's going to be decay if your base is a fraction in between 0 and 1. And growth exponential functions look like that. They're increasing from left to right, and decay functions look like this. They are decreasing from left to right. So growth or decay. So now what we're going to do is we're going to look at your h value. So your h value is up in the exponent here. So it's with the x. So notice if h is minus there, it's going to move to the right. So this is going to move the graph right if it is something like x minus 2 up there. And it's going to move the graph left if it's x plus 2. Now it is going to be backwards of what you think it is. So if it's minus 2, it's to the right. If it's plus 2, it's to the left. So it's kind of the opposite of what you think it might do. And then the very last one is your K value. So looking over at the graph on the right, the K value is just going to move your graph up and down. Okay, so I'm going to do this full screen now. Your K graph is going to move the graph up or down. Up is if it's going to be like plus 2 at the end. Down would be if it was minus any number at the end. So the K is going to do exactly what you think it should do. So plus moves it up, minus moves it down. So let's use that to try this problem down here. Okay, so I'm going to zoom out so you can see everything. So first we're going to deal with the -4. So identify the transformations based off of this. So the -4 here is going to mean that the negative sign here reflects over your x-axis. That's because it's the negative. The 4 makes it a vertical stretch of 4. So those are your A things. Your base here is 1/3, which means it's going to be a decay function. So it's not really changing the transformations. Really, it's just what the original graph looked like. It would be a decay function. Your h value is going to deal with this +6. That's your h. So since it's plus, up here you can see that the plus moves it left. So this graph is going to be moved left 6. And then your k value is being added at the end. So since it's plus 7, that's going to move your graph up 7. What's going to happen in the future is we're going to be able to take a decay function. We're supposed to be able to stretch it, reflect it, move it left and up. So we'll start taking our graphs and actually moving them all around in the future. But right now, what we need to be able to do is look at an equation and identify how it's going to be moved. Okay, so I hope this helped. We can go over any questions that you have when we're back in class. Thanks.